Faraday's law, shown here in this boxed equation, says that if the magnetic flux through a loop changes, then an induced EMF appears that opposes this change in flux. We can also approximate this induced EMF as its change in flux per change in time. Let's look more carefully at the sequence of events. First, magnetic flux changes. That could happen by the magnetic field changing, the area of the loop changing, or the relative angle between those two changing as well, or a combination of all three or so. Anyway, if flux changes, then an induced EMF appears. That induced EMF then causes an induced current to appear. We can find the magnitude of that current using Ohm's law, and then that induced current causes an induced magnetic field. All of these events again happen so as to oppose that change in flux that occurred. While we can use Faraday's law to find the magnitude of the EMF and Ohm's law to find the magnitude of the current, we don't yet have a way to find the direction of the induced current or the direction of the induced magnetic field. And that's where Lenz's law can help us. For Lenz's law, we're going to ask ourselves, does the magnetic flux increase or decrease? And depending on our answer, we'll then use our right-hand rule for loops to find the direction of the induced B field and then find the direction of the induced current. If the magnetic flux increases, then the induced magnetic field is going to point in the opposite direction of the original magnetic field. The induced field is going to point in the other way so as to add some flux that tries to undo that increase. Knowing that, we use our right-hand rule for loops and point our thumb in the direction of the induced magnetic field and curl our fingers to find the direction of the induced current. If instead the magnetic flux decreases, then the induced magnetic field is going to point in the same direction as the original magnetic field. We're going to add more field to try to bring the flux back up to what it was at originally. Knowing that, using our right-hand rule for loops, we point our thumb in the direction of the induced magnetic field, curl our fingers, and that gives us the direction of the induced current in the loop.